How could an open fire roar in the heart of the Scandinavian winter, when hurricane-force winds seemed certain to blow out any spark? The Viking Age is associated with the sea and steel, but neither is conceivable without fire, the fire that burned in the forges located on the windiest coasts of the world. When an icy storm swept across the fjord, plunging the settlement into chaos, the hammer in the forge continued to sound. This was no miracle, but the result of ingenious engineering, a deep understanding of nature, and incredible human endurance. These workshops were the heart of the community, and their shutdown would mean rapid demise. Watch the video to the end to discover the architectural secrets and incredible human perseverance that allowed the heart of the Viking, its forge, to beat relentlessly in the icy storm. I will reveal the most closely guarded secret. For the Viking, the forge was not just a workshop, but a place of power, an almost sacred space. Here, hard, dead ore turned into living, singing metal, capable of protecting and feeding. This act of creation was akin to magic, and the blacksmith was often perceived as a person with a special connection to divine powers. The fire of the forge was not just a technological process, but a living entity that demanded respect and constant care. Therefore, preserving this fire was not only a practical task, but also a ritual one, a matter of honor for the entire settlement. The forge, where swords and plows were born, was a symbol of stability and order in the midst of wild nature. The winter storm was the embodiment of chaos, and the forge working against it became an act of affirmation of human will. The sound of the hammer, heard through the howling wind, was a signal. We are here. We are strong. We will survive. This almost sacred status determined the first and most important decision: the location of the forge. Forges were never built on open hilltops exposed to the winds. That would have been impractical and foolish. Instead, Scandinavian craftsmen sought out natural shelters which nature provided in abundance. They used the topography as their main ally in the fight against the elements. The ideal location was considered to be a hillside facing away from the prevailing winter winds. The forge was often built so that its back wall was completely buried in the ground. This not only provided incredible protection from the wind, but also utilized the geothermal heat of the earth, acting as a natural heat accumulator. This arrangement required serious earthworks, but the result was worth the effort. If there was no suitable slope nearby, craftsmen looked for natural depressions, hollows, or even the edges of dense forests. Trees served as a powerful living windbreak, breaking up a single stream of hurricane-force wind into thousands of smaller and weaker eddies. The settlement itself, with its long houses and farm buildings, created a complex wind protection system. The smithy was located within this perimeter, in the quietest and most sheltered place. The entrance to the workshop was almost always located on the leeward side, often on the east or southeast. This was critically important, as the prevailing winter storms in Scandinavia most often came from the west and north. Thus, even when a blizzard was raging outside, it was relatively calm at the entrance to the smithy. The doorway was made low and narrow to minimize drafts. The choice of location was the first, and perhaps the most important secret to the forge's resilience. The Vikings did not try to fight nature openly. They adapted, using its own power against it. They integrated their creation into the landscape so that it became an integral, protected part of it. It was a strategy of integration, not confrontation, and it worked flawlessly. Construction began with a deep stone foundation that went into the ground. This foundation served not only as a base, but also as the first barrier against the ground freezing. thick logs were laid on top of the stones, forming the frame of the future workshop. Already at this stage, the future stability of the building against incredible wind loads was laid down. The first stage was complete. The smithy was hidden from the direct wrath of the elements, but now it had to be built in such a way that it itself became a fortress. We would be very interested to hear your point of view. What do you think about such a deep connection between the choice of location and beliefs? Write about it in the comments and be sure to subscribe so you don't miss our research. Are you ready to learn the truth about how Viking forge walls were often alive? Once the location was chosen and the foundation laid, the second stage began. Building walls that would serve as armor against the icy wind. Here, the Vikings used a material that was literally at their feet and had unique properties. We are talking about turf, thick layers of earth tightly bound by grass roots. It was not just construction waste, but a high-tech composite material of its time. The turf was carefully cut into long rectangular blocks, similar to giant bricks. These blocks were heavy, dense, and held their shape well.
The completed turf walls of the forge, strong and dense.
The walls of the forge were often built using a double technology. The inner frame was made of wood, and the outer wall was laid out with these sod blocks, like bricks. The thickness of such a wall could reach a meter or more. This created incredible thermal inertia, making the building impervious to sudden temperature changes. Sod had fantastic insulating properties. The air trapped in the complex structure of soil and roots created a barrier that neither frost nor wind could penetrate. In winter, such a wall prevented heat from escaping, and in summer it kept the interior cool. It was an ideal, environmentally friendly, and completely free insulator. In addition, the turf wall was breathable. It slowly allowed moisture to pass through, preventing condensation from forming inside the room, which could be a problem in a hot smithy. At the same time, it was completely impervious to wind. Not a single draft could penetrate the meter-thick layer of compressed earth. From the outside, the smithy looked like a natural part of the landscape, a low green hill with smoke rising from it. In spring and summer, grass began to grow on the walls and roof, further strengthening the structure with its roots. It was living architecture, fully integrated into the environment. The roof was also the subject of special attention. It was made gabled, but with a very slight slope to reduce wind resistance. The rafter system was first covered with a layer of boards or poles, then several layers of birch bark were laid as waterproofing. Birch bark did not rot and was completely waterproof. The result was a building that looked more like a bunker or dugout than a light structure. It was low, heavy, and incredibly durable. It was not afraid of snowdrifts or hurricane-force winds. But how did smoke escape from such an airtight box? In the next chapter, we will reveal how unique building materials turned walls into impenetrable armor against the cold. Guess which essential element of a modern furnace was completely absent from a Viking forge? If you imagined a tall stone chimney, you are mistaken. The Vikings did not have chimneys as we understand them today. Their absence was not a shortcoming, but a conscious design decision dictated by harsh necessity. A tall chimney creates strong but uncontrollable draft. In winter storms, it would turn into a giant pump, sucking heat out of the room. Moreover, a gust of wind could create reverse draft, filling the forge with smoke or even extinguishing the flame in the furnace. The Vikings needed a system that could be controlled. The heart of the forge was the furnace, a stone hearth where coal burned. It was not located in the center, as in a residential building, but against one of the walls. The smoke from the forge rose up to the roof, where there was a special smoke vent. It was called a yur and was much more complex than a simple hole in the roof. It was a rectangular opening, often lined with wood, located on the ridge of the roof. It was equipped with a special wooden damper or a whole system of wind skids, wind boards. The blacksmith could adjust the size of this opening, and sometimes its direction, using a long pole. This allowed him to tune the draft depending on the strength and direction of the wind. In a strong storm, the blacksmith could cover the opening almost completely, leaving only a small gap. This was enough for the smoke to slowly escape, but at the same time, gusts of wind could not penetrate inside. The system required constant attention. If the damper was closed too tightly, the forge would fill with carbon monoxide. If it was opened too wide, the furnace would start to run wild. But smoke removal is only half the equation. Combustion requires a supply of oxygen. In an airtight forge buried deep in the ground, this was no trivial task. Normal ventilation through the door was out of the question. It would create a draft and cool the room. Therefore, the air supply system was as well thought out as the smoke extraction system. Small, inconspicuous holes were made in the walls, close to the floor. They were often hidden in the stonework of the foundation or in the thickness of the turf wall. These holes were directed so as not to catch gusts of wind, but to create a slow, constant circulation. Cold, heavy air from the street entered and spread across the floor. Controlling this breath was the highest art of the blacksmith. He had to feel the slightest changes in the behavior of the fire, hear the wind beating against the roof, and adjust the damper in time. He was not just a craftsman, but the operator of a complex climatic machine that he himself had built. If you appreciate such a deep dive into the history of the craft, please support our channel with a like. What if I told you that everything you knew about blacksmithing fire was wrong? The fire in a Viking forge could not exist on its own, even with perfect draft. A simple bonfire, even with the best coals, would not provide the temperature necessary for welding iron. The secret of the unquenchable flame lay elsewhere, in the constant forced injection of air. Blacksmith bellows, or meblosa in Old Norse, served this purpose. These were light forges, and they worked non-stop. In the Viking era, simple but effective wedge-shaped or pear-shaped bellows were most commonly used. They consisted of two wooden boards connected by a wide strip of leather. The design was simple and reliable. One of the boards had a hole with a leather valve that let air in but did not let it out. On the other, narrow end, there was a metal or wooden nozzle that pointed directly into the heart of the furnace. The blacksmith or his assistant rhythmically compressed and decompressed these lungs. It was this technology that was the main answer to the question of why the fire did not go out. The stormy wind could howl outside, trying to penetrate through the smoke hole, but it was powerless against the concentrated, powerful stream of air that the bellows blew directly into the coal. This stream was stronger than any draft. Working with bellows was an art in itself and required superhuman endurance. Most often, this was done by an apprentice or assistant to the blacksmith. He had to maintain a constant, steady rhythm for hours on end. Too strong a flow could blow out the heat from the furnace and burn valuable coal. Too weak, and the metal would not heat up to the required temperature. Some smithies used more sophisticated two-chamber bellows. This system allowed air to be supplied continuously. While one chamber was filling with air, the other was being compressed, blowing air into the furnace. This ensured an even, powerful, and non-pulsating flame. The bellows nozzle was inserted into the furnace through a special hole in the masonry called a fuse. This was a clay or stone tube that protected the wooden or leather tip of the bellows from the heat. It was at this point, where the air from the bellows met the hot coal, that the extremely high temperature was generated. The secret of the heat capable of melting steel lay not only in the bellows, but also in the fuel. The Vikings almost never used ordinary firewood in their forges. Ordinary wood contains too much moisture and resin, which when burned produce thick smoke, steam, and insufficient heat. Real blacksmithing required something much more effective. That fuel was charcoal. This is not the coal that is mined from the ground, but a product of the dry distillation of wood. The Vikings were masters at producing it. The process was long and laborious, and was carried out by specialists known as charcoal burners. They built special piles or pits in the forest where the wood slowly baked without access to oxygen. As a result of this process, all moisture, resins, and other volatile substances were removed from the wood. Only pure carbon remained, a light, porous, and incredibly energy-efficient material. Charcoal burns with almost no smoke or flame, but provides a stable, even, and incredibly strong heat. It could heat a forge to temperatures above 1,000 degrees Celsius. This was precisely the temperature required for forge welding, a process in which two pieces of iron were joined together by hammer blows. It would have been impossible to achieve such heat on a normal wood fire. Therefore, charcoal was a strategic resource, the black gold of the Viking era. The quality of the charcoal was of paramount importance. The best charcoal was obtained from hardwoods such as oak or beech. It was carefully sorted and, most importantly, stored in absolutely dry conditions. Wet charcoal was useless. Therefore, the smithy always had special dry chests or pits for storing fuel supplies. In winter storms, the value of this resource increased many times over. The blacksmith could not afford to waste time lighting damp wood. He needed material that would ignite instantly and immediately reach the required temperature. A bag of dry charcoal was a guarantee that work would not stop. The process of burning coal in a furnace with forced air supply was very intense. The coal burned quickly, and the blacksmith had to constantly add new portions. This required skill. It was necessary to add coal in such a way as not to smother the fire and cool the working area. Are you ready for the shocking truth? The forge itself was not just a shield, but a giant battery. The entire structure, from the foundation buried in the ground to the massive turf walls, had enormous thermal inertia. It was not just a shelter, but a heat accumulator that helped the blacksmith in his struggle. The massive stone forge, the hearth lined with clay and stones, and even the stone support for the anvil absorbed heat during work. They heated up to high temperatures, and then very slowly, over hours, gave this heat back to the room. This physical feature was a key element of survival. Even if a storm blew out the fire for a moment, the hot stones of the forge would not allow it to go out completely. They retained enough heat to reignite the flame. This created a stable thermal environment that smoothed out any sudden changes. The forge, where they worked every day, never cooled down completely. The turf walls and heavy roof also accumulated the heat radiated by the furnace. After a few hours of work, the entire building turned into a single warm cave, and the outside storm could no longer cool it down so easily. But all this ingenious engineering, the layout, materials, bellows, and coal, would have been useless without one key element. That element was the blacksmith himself. It was his experience, endurance, and intuition that made the system work. He was the keeper of the fire in the truest sense of the word. The blacksmith had to be a meteorologist, engineer, and physicist all at once. He had to determine when to close the damper by the sound of the wind. he had to see by the color of the flame whether there was enough oxygen and whether it was time to add coal. He was the brain of this complex system. Working in the forge during a storm was incredibly difficult. The constant clanging of the hammer, the roar of the bellows, the howling wind outside, and the acrid smoke created hellish conditions. It required not only physical strength, but also tremendous psychological resilience. During the long, dark months of the Scandinavian winter, when the settlement was covered with snow and the sea was frozen, life came to a standstill. The days became short and the nights endless. During this period of cold and isolation, the forge took on additional significance, not only industrial, but also social. It was one of the few places in the settlement where it was always not just warm, but hot. The heat radiating from the forge was a real luxury. While the longhouses were heated only by a central hearth, the smithy was like a volcano. This naturally attracted people to it. The smithy became an informal men's club, a place where you could not only warm up, but also discuss business. Warriors came here to repair their weapons or order new ones for the spring campaigns. Farmers stopped by to prepare their tools for the coming plowing season. Sailors brought ship equipment that needed repair. Here, in the warmth and dim light, amid sparks and the clang of metal, leisurely conversations took place. The sound of the hammer set the rhythm for these winter days. The smithy became a kind of news and social center where information and plans for the future were exchanged. The blacksmith himself, in addition to his main work, often acted as a sage or judge. His skill and power over fire and metal commanded deep respect. People listened to his words, and his workshop was a place where many disputes were resolved and deals were made.
As you command, the clan will honor your decision, master.
This social aspect was another reason why the fire had to burn. A working smithy was a sign of a living, functioning community. It gave people not only warmth and tools, but also a sense of community and confidence in the future. As long as the hammer could be heard and smoke curled from the chimney, life went on. This was especially important during severe storms, which could last for weeks. The storm isolated people from each other, and the forge was the point that united them. Maintaining a fire in an enclosed space during a storm was not only a technical challenge, but also a serious safety issue. The forge was a place where a fire could break out at any moment. Sparks from the furnace, red-hot metal, dry coal, all of these posed a constant threat. The Vikings understood this, and the design of the forge took these risks into account. First, the floor of the forge was almost always earthen or clay. There was nothing to burn on it. Any spark that fell on such a floor simply went out. It was the simplest and most effective solution. Second, there was always a large container of water next to the furnace. It was not just a barrel, but an integral technological element. Water was needed to harden the metal and make it strong, but its main constant function was fire safety. The blacksmith used water to control the fire in the forge by wetting the coals around the edges. He dipped red-hot tools and blanks into it. The same water was used to instantly extinguish any accidental fires. During a storm, when outside help might not arrive, this barrel of water was a lifesaver. The interior of the smithy was minimal. There was nothing superfluous that could catch fire. Only the ceiling beams, which were high above the furnace, and the workbenches near the walls were made of wood. The walls, lined with stone or covered with a thick layer of clay plaster, were also fireproof. The problem of carbon monoxide, which inevitably formed when coal burned, was also solved by design. A ventilation system with air intake at the floor and exhaust at the ceiling was vital. It not only fed the furnace, but also prevented the blacksmith from suffocating. The blacksmith had to have a feel for carbon monoxide. Any change in the behavior of the fire, the appearance of bluish flames, or slight dizziness, was a signal to immediately adjust the draft or open the door for ventilation, despite the storm. Why was it necessary to put in so much effort and keep the fire going in the forge, despite the fury of the elements? The answer is simple: the work could not wait. The Viking economy, based on agriculture, trade, and military campaigns, was completely dependent on metal. Winter was not a time for rest, it was a time for preparation. It was in winter, when the fields were covered with snow and the ships were moored in frozen fjords, that the blacksmith had the most work. Farmers brought their plowshares, hoes, and scythes to be repaired. Everything had to be ready for the short spring season. Warriors prepared their equipment for future campaigns. Winter was the time for forging new swords, arrowheads, and spearheads, as well as repairing helmets and chainmail damaged in battle. These orders were the most prestigious and required the highest level of skill from the blacksmith. But the most mass-produced and vitally important products were nails and ship rivets. Viking ships, the famous Drakars and Norse, were the backbone of their civilization. In winter, they were repaired and new ones were built. Thousands of rivets were used for each ship, and each one came from the forge. Stopping the forge in winter would mean that in spring the farmers would not be able to plow the land, the warriors would go on campaign with poor weapons, and the ships would not be ready to sail. It would be an economic and military disaster. Therefore, the blacksmith was a key figure, on whose work the well-being of all depended. The storm was not a reason to stop work, but merely an unfortunate circumstance that had to be overcome. While the wind howled outside, the blacksmith methodically transformed pieces of bog iron into the tools of civilization. The sound of his hammer was the economic pulse of the settlement. When we look at archaeological finds from the Viking Age, elegant swords with Damascus steel patterns, complex ship rivets, simple but functional axes, we must remember the conditions in which they were created. Each of these items bears the mark of a struggle against the elements. The unquenchable Viking forge is not just a building. It is an entire system, a complex organism in which architecture, technology, and human will were woven together. It is a monument to the engineering genius of a people who learned to live in harmony with the harsh natural environment without submitting to it. Its location in sheltered lowlands, thick turf walls that functioned like a thermos, and heavy roofs that pressed the house to the ground were all responses to the challenge of the wind. A controlled ventilation system, with air intake at floor level and adjustable exhaust, was the answer to the challenge of smoke. Bellows with forced air supply and high-calorie charcoal were a technological breakthrough that made fire independent of the weather. They allowed not only to maintain heat, but also to achieve the ultra-high temperatures necessary for complex metal processing. And above it all stood a man, the blacksmith, the keeper of the fire, the master who conducted this complex orchestra. His knowledge, endurance, and perseverance were the last and most important barrier that the storm could not overcome. We see that behind the myth of the Vikings' unquenchable fire lies cold calculation, ingenious engineering, and incredible perseverance. It was not magic, but the perfect synergy of architecture, technology, and a deep understanding of the laws of nature. From the choice of a location buried deep in a hill to the living turf walls that functioned like a thermos, from hand-operated bellows that shouted down any wind to the most valuable charcoal that provided clean heat. What do you think about this incredible synergy between man and nature? What other aspects of Viking life or crafts would you like us to explore? Suggest topics for future videos in the comments, and don't forget to subscribe so you don't miss our next journey into the past.